Welcome to video 3, using the nth term on quadratic sequences by B-Dogs Maths.
Hi guys, so we are on video number 3 now, which is quadratic sequences, and that is grade 8, so it's grade 8, grade 9, which is top end. The quadratic sequence is a sequence where the terms do have a mathematical link between them, but it's not as simple as an arithmetic one. It's a little bit more complicated. Okay, so what I'm going to do, I've got two quadratic sequences already played out for you. I'm going to show you how you prove that they are quadratic sequences by showing how they are linked, and also how to establish the relationship between that sequence and a particular sequence of the counting numbers that we've discussed previously. Alright, so here we have two quadratic sequences. The top one, I'm going to first establish that it is quadratic, and it will be if I first look at the difference between these two numbers. So between 4 and 8, I've got a difference of 4, then I've got a difference of 6 between these two, and a difference of 8 between these two. I think that's correct, isn't it? Yes, it is. I'm going to go for my second line of differences though. So I'm looking at how these differ. I then get a line of difference of 2 between each. As long as the second line of differences is constant, in other words, it doesn't change, which is 2 followed by 2 followed by 2 and so on, then I have a quadratic sequence. This quadratic sequence is related to n squared. So my counting numbers, my natural numbers squared, and remember, you should know the first 15 of those off by heart. Okay, so that's the first bit there. Let's do exactly the same maths on this one here. So again, 4, 8, so that's a difference of 4, but this time it jumps to 16 rather than 14, so that's a difference of 8, and then it goes from 16 to 28, which is a difference of 12. So that shows that the second line of differences here is 4 here, but now it's also 4 here. So the second line is constant, so it is a quadratic, but this one's related to 2n squared. And the idea is, not how I know that is because I take this value that I've just worked out, I divide it by 2, and it gives me the coefficient that goes in front of here. And you should know, if I don't see how many n squareds there are, that I know that's 1n squared. Here, do the same maths here, divide by 2, I end up with 2, and that's where 2n squared comes from. Okay? Cool. So now you know how to establish what sequence your quadratic is related to. We then have to ensure that we are able to write down those sequences down. So let's have a look at our main one, n squared. N squared, we should know, starts off with 1 because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on. And then all my other versions of n squared are linked to this one. So 2n squared would be this sequence multiplied by 2. So 2, 8, 18, 32, and so on. 5n squared would also be related to this by multiplying this by 5, and so on. Okay, so that's how we establish 2n squared, 3n squared, 4n squared, because you're going to need that skill as well when dealing with harder quadratics. These are quadratics in their own right, but these are basic. What you need to work on with your grade 8, grade 9 are more complicated ones than these, things that need a little bit more working out. And for that, I'm going to go over to my computer, because my computer will then help me to do this much more clearer for you. Okay, so I'll see you on my computer, guys. B-Dog's back in a bit. Alright. Hey everybody, so I'm back here on my computer again, and we're going to answer a couple of questions using what we've just looked at regarding a quadratic sequence and our nth term, and our understanding that this is all related to that natural sequence of numbers, the counting numbers. So what I need to look at here, let me just check the thickness of this line. I knew it. Okay, cool. So what I want to look at is the differences between here. I need to establish what is going on between these numbers. It tells me it's a quadratic sequence. So I know it's going to do what I'm looking for anyway, but still. 9 goes to 13 in a plus 9, 10, 4. Yep. And then here, this one is adding 13 at 6. And then this one is adding 8. Alright, so you've managed to find out the differences between these numbers. So I know it's not arithmetic, because if it was, these 3 would be the same, but they aren't. So what I look at again then is the second line of differences. My second line. So my second line of differences here is 2, and then another plus 2. So from 4 to 6 is 2, from 6 to 8 is 2. This number directly tells us what sequence this sequence is related to. And the sequence this is related to is n squared. The way I know that is by taking this value that I found as my second line of differences, dividing it by 2, dividing it by 2. Oh my gosh, what am I doing? 1 second. Dividing it by 2. And that gives me the coefficient that goes in front of this n squared, which is 1. But as you know, we don't say 1n squared, hence why I leave that off. I just call it n squared. So dividing by 2 takes me to this thing here, and it tells me I'm related to n squared. Okay, so that's my first point. I know that this sequence is related to n squared, which is therefore a quadratic sequence. So the first thing I'm going to do is I'm going to write down what my n squared is called. So n squared is squaring the counting numbers. So that gives me 1, 4, 9, and 16. If you don't know this, you need to learn the first 15 square numbers off by heart. Alright, it's 1, 4, 9, and 16. I know that this is not exactly this sequence. This sequence that I'm looking for, I don't know, let's call the name of the sequence, I'm not sure. I'm looking for the nth term, I'll leave it as the nth term. When I'm teaching this in school, I use random names like Bob and Fred and Jane and stuff here, just to make it a bit different. But it's the nth term I'm looking for of this sequence. And I need to know how this, the nth term of this is different to the answers I've got here. So I'm doing a subtraction from the nth term, and I'm going to take this away so I can find out what the difference is. So the difference of this, so nth term, or Bob or Fred or Jane or whatever teacher you're choosing to use, take away my n squared. That gives me the following sequence of 8, because 9 take away 1 is 8, 13 take away 4 is 13, 3, that's 3 to 10, and 6, 3 and 6 is 9, and then 19 take away 9 is 10, and 27 take away 16 is 11. Okay, so I've now got this. Alright, let's just change colour. So I did nth term, take away the n squared, gives me these values here. What I'm saying then is that this sequence is actually called, it goes up in ones, so it's related to the counting number directly, but my counting numbers would start off with 1, this starts off with 8, so I'm going to add 7 to make that correct. So, the nth term, take away n squared equals n plus 7. Yeah, so that equals that, which it does. And my answer therefore is that the nth term then must be, if I can add n squared to both sides, n squared plus n plus 7. And that's how I find the nth term to my sequence. Right, so that's one question done for you. Right, so here's a question for you to have a go at. Pause me, and then I'm going to show the working out to it in order, but not speak. It's going to be quite quick, but you'll be able to pause it in your own time. So pause me now, and I'll see you in a little while. Right, so Here we go. Here's your answers. Watch carefully. Cool, it's going down in minus ones. So it's minus n. Should start with minus 1. If it doesn't, it starts with minus 7. So that's take away 6. And we have our answer. Woo! Okay, so have a look at that again and see how you get on with that. On to our next problem. Here's one where we have got just to work out one of the numbers in my sequence. And the key thing is, if you understand what we talked about, this counting number, this natural number, we're looking for the 10th of our sequence, knowing that it's related to the natural sequence. The natural sequence in the 10th term would be number 10. The natural counting numbers would give me number 10 at that point. So I'm going to use that number 10 in here. So what I'm going to do is I'm going to work out what 2 lots of 10 squared plus 4 lots of 10 minus 1 will work out to be. 10 squared is 100, so that value there is worth 200. 4 times 10 is 40, so that's worth 40, and obviously take away 1. So my final answer to this question is actually 239. Okay, hope that's clear. On to the next. Here we have another one. This time we work out the first 5 terms of the sequence. Sometimes you can just do it in our head, sometimes show our working out. I'm going to just show my working out for the first couple, and I'm going to leave you to do the rest. So for the first one, I'm going to work out, I'm going to do 1 squared plus 2 lots of 1, because that's going to give me using the counting number 1 as my first term. 1 squared is 1 plus 2 is 3. Then to find the second position or second term, I'm going to be using 2 as my version for n. And that's going to give me 4 plus 4, which is 8. And I'll do one more. 3 squared plus 2 lots of 3 gives me 9 plus 6, which is 15, and so on. Okay, so that's how you'd answer that question. And that's pretty much all the different ways that you're going to get asked questions about the quadratic sequence and how to work out use the nth term of them. Alright, hopefully you enjoyed that.
BDog would like to thank you for watching, and hopefully you will comment below for some more. Oosh!